Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Technology is rapidly changing the way we design, manufacture and install our buildings. Eric Karsh is the founding partner of Equilibrium, which is a Katerra company, and they're looking to make major changes to the way we build. In this episode, we have a discussion about costing and designing a project with parametric modeling, optimisation for prefabrication and installation, and utilisation of building information modelling to improve the design and construction process. Now, I really enjoyed this very forward-thinking discussion with Eric, and I'm sure you're going to enjoy this interview. So without any further ado, here is the episode with Eric Karsh.
Yeah, we've been designing with timber for over 25 years now, and we've always been trying to innovate with the material. It's a material that we love working with, and through those 25 years, we've seen progress at the beginning with the technological side of the material, so new manufacturing techniques, CNC fabrication, new connection systems, which are a lot more efficient. There was a big shift when CLT entered the market. That allowed us to build bigger and taller buildings, and using the technology that we had been experimenting with before that gave us the tools to put together some projects that were new for the timber industry. And we're talking about university buildings, which traditionally are made out of concrete, and certainly high-rises, which were not thought of possibly being built out of wood before. So that technological shift certainly happened fairly quickly. What we're seeing now, though, is quite different. What we're seeing now is we're seeing all that technology and all the demonstration projects that we've done that has proven that this technology can do what we know it to be able to do now, and has convinced the market, the developers, to now use the material for the advantages that have been demonstrated. So speed of construction, it's a lighter material than concrete, certainly. It's a beautiful material, and it's a green material. But now, with all the demonstration projects that have come before that, we're entering a phase where the market wants those buildings. The demand is growing very fast. The supply line is certainly growing very fast as well. So it's a different change. It's not about the technology now, it's about the market.
Has there been a change in paradigm also? Yesterday, when you were speaking on stage, you mentioned how you put a case for a 30-story tall building with Michael Green, and you were scoffed at only a few years ago. Is that correct?
Yeah, just 7 years ago, the blogs were filled with comments of in some cases, it was outright criticism. In some cases, it was disbelief or skepticism. And quite frankly, when we started this feasibility study, we were taking on a study for a 12-story building. Michael Green went to Japan with his son, saw a temple there that was 1,000 years old, that was about the same height as a 12-story building, came back saying, they did it 1,000 years ago, we can't be doing 12 stories, we have to do 20. So we're going to take on 20, and then we developed an idea for that, and it was working surprisingly well. So I told him that, but I said, don't tell anybody. But he went to Australia and did a conference there, and then spoke to a journalist afterwards saying that we could do up to 30. And then next thing I knew, it was in the papers. So we were stuck with a 30-story challenge. And so we analyzed 30-story structures and found that it actually could be done quite easily using certain lateral resistance approaches. So, and then after that, we redesigned the Empire State Building out of wood as a marketing project for Metsä Wood in Scandinavia. So the technological challenges, I think, have been taken on and addressed and talked about quite a lot. people have seen many people over and over saying this can be done, this can be done. I think we've passed that hurdle. People now realize that technologically timber buildings work.
As Equilibrium is a Katerra company, and how is your approach to design different, especially with the whole idea of the kit of parts approach, and which what I understand is what Katerra is trying to deploy?
Right. So, I mean, we've only been with Katerra for a year, so it's still relatively new. About half of our team is quite dedicated to product development, so focusing on repeatable design and optimizing those designs to a very high degree. We also have about half the team that still does projects that were in our pipeline back then and just delivering on commitments that we had. But the intent is that even under Katerra, we would be doing new projects, offering even in some cases just engineering services to clients who want a Katerra-based design, whether it actually carries on and becomes a Katerra-delivered project or not, or Katerra manufactured project.
Yeah.
So we're still doing a lot of custom design, sometimes for Katerra clients, sometimes for old clients.
And you mentioned how your team is working on optimization. Where do you see the highest potential for optimization, whether it's through design all the way through to installation?
Yeah, so the great thing about Katerra is that we have unbelievable resources supporting us in doing things that small engineering firms typically just cannot do. So we have some programmers that develop parametric tools to help us do what we do. We have similar tools helping with the actual production process, certainly for repeatable products. But the idea is that the software is aimed to streamline the process from beginning to end. And one thing that I'm very excited about is parametric modeling of timber structures that will allow us to look at hundreds of permutations at the very, very beginning of the project so that we can value engineer almost in real time in front of the client and give them the information that they need to make key decisions. Value engineering is usually something that comes in later. I mean, we all have a sense of what's economical and so on, but it's very hard to look at 100 different options at the very beginning of the project and put costing to it. I mean, that's the hard part, is to actually cost it all. But with parametric modeling, you can do that, as long as you have the cost data available to you, which would be in this case with a company like Katerra.
Yeah. And then with parametric modeling, do you think in the future you'll be able to use what you've used on one project and apply it to a whole range of different projects to jump an extra step?
Absolutely. So this is a live process, right? So you constantly loop the information back into the data bank.
Yeah, I saw a presentation at the World Conference on Timber Engineering last year, and it was the concept of designing the logic that designs the structure, and then if the architects got access to this model, then they can change the roof pitch themselves, and the computations automatically do themselves in the design.
Yeah, and I guess that leads to a key question. Are architects and engineers going to get replaced by parametric modeling? And the answer, in my mind, is clearly no. They're tools, and they're very powerful tools, but at the end of the day, if you don't guide that tool in the right direction, it's going to give you garbage. So, parametric modeling is going to take away a lot of the repetitive and tedious aspect of our work out and allow us to focus on the more creative aspects, I think.
Yeah. And then the next step in that process would be the design, whether it's parametric modeling or not, or building information modeling, and how easily can that speak to robotics and the actual CNC machines inside the factory, and is there still a lot of potential in that communication and interaction?
Yeah, I mean, BIM is all about tying the different processes together, but I don't think it's actually truly been achieved yet. Uh, and Katerra has taken on that problem head on. They've decided to develop a platform called Apollo, which is a software package that will actually tie all aspects of that process from schematic design all the way down to manufacturing. It's a huge task, and we're launching different parts of it to users already. But the goal is that that suite of software, which is fully integrated, is going to be available to Katerra and other users in the fairly near future.
Yeah, that's exciting. Inside the factory, where do you see the future there in 3D modular or prefabrication, and what kind of value can be added inside the factory for faster construction and better value?
Right. The obvious one is quality. The manufacturing process in the plant is significantly more accurate and reliable than it is in the field. But also the ability to replicate processes in a much more efficient way than we have been before, and developing platforms that can be modified. And as Michael Marks pointed out yesterday, your buildings can look completely different from the other, but the platform is the same. And that repetition allows us to truly optimize, to truly make your design as efficient as you possibly can make it. But with artificial intelligence and other aspects of the process that we can modify, you can still achieve a fairly high degree of custom design. So, and I think there was another speaker yesterday, Anthony Thistleton, pointed out that if you design something once, you're lucky to achieve an 85% degree of perfection. If you do it 100 times or 1,000 times, you get a lot closer to 100%. So that's the idea there. Yeah, just a few years ago, people who were interested in putting together supply lines, or Nordique as an example, about 8 years ago or 9 years ago, of course, were worried that the market wouldn't support their investment. And that's always a concern. There is no doubt, for reasons that I've explained before, now we're going from demonstration projects to market-driven projects, developer-driven projects. The demand is going to grow really fast. There is still a concern that if the supply grows too fast, it's not going to get it's not going to get good economic return. So I think you need to be cautious at bringing more supply into the market. On the other hand, it is coming very fast. So Katerra, for example, opened a new plant 10 days ago that is going to triple the North American supply of CLT. There's another supplier in BC that's going to open a plant a little bit later. So, and I know that the European CLT suppliers are building plants very quickly, and they have an 8-month backlog. So the demand is growing really fast. The supply is trying to keep up with it. It's understandable that suppliers don't want to get ahead of the demand too much. But I think you're going to see the supply continue to grow. And what that does, and this is key, is that it brings stability to pricing. It brings stability to the process so that projects are delivered on time. Timber in Canada certainly used to be a very small, kind of family-oriented industry. Now it's becoming a big mainstream industry, and that can only be good, to help convince users and owners to use the product. Well, you need to take the first step and give a first project a try. This is how we did it. My partner Robert actually studied timber engineering at school, so he had a head start. But when I first designed with timber, which was 7 or 8 years into my career, the first project was hard work, but I gained a significant amount of knowledge on that project and through that process. And then a second project, a third, a fourth, and eventually you're a timber expert.
Yep.
So you just take it on and take the time to go to conferences, take the time to learn about the material, and it's a fun material to work with. I will never regret jumping into the world of timber.
Yeah. And my final question is, what are your thoughts on the future of timber construction?
Right. So, I mean, we used to work with timber centuries ago. We used to build cathedral roofs with timber. We used to build houses with timber. And then steel and concrete through the Industrial Revolution came around. That was maybe 120, 130 years ago. And a lot of research and development took place with those materials. And, through 130 years, I think we've refined timber and, steel and concrete most of the way. And there's, in my mind, some place for progress with those materials, but it's probably relatively limited. Timber as a high-tech material is quite new, and the research and the development of new products, the development of new connection methods, and so on is all relatively new. And I think the potential for improvement, for more efficient design and construction is wide open, and I think that is going to continue to progress very quickly. What that means is that timber construction is going to become more and more competitive, and as it becomes more and more competitive, combined with an increased sense of urgency to deal with the environment, I think means that timber is going to take a bigger and bigger part of the market. And it will do so in all types of construction, from housing, where it currently occupies a very big part of the market in North America, to commercial construction, including high-rise or mid-rise buildings. Yeah.
If you've got a question about wood, I recommend you go to the Wood Solutions website, where you will find our Wood Solutions technical design guides. So all of these guides are free, and they've got some of the best experts around the world going deep in detail into topics such as costing, structural design, fire, durability, and so forth.